Hey guys, welcome back. I hope you watched the questions 1 through 10. And now you're ready to dig your teeth into some questions about the free response. All right, so I'm gonna pull in, and I hope you do too, just some extra paper here. So I'm just gonna, cover up some problems just so we have some room here to work. And yeah, stretch that out here. Okay. And the first question is 211. It says the dot plot gives the sale price for 40 homes. So we talked about this, that homes especially, anything having to do with how much money we make is oftentimes skewed right. So we see some really big values of homes that are going to pull the mean to the right. It says these were homes in Ames, Iowa, sold just during the recent month. The mean price was 203. So looks like the mean maybe was somewhere right here. And the standard deviation was 87. So a typical house varied from the average by 87,609. Okay. So let's just see what the scale means. If that's each bin width or number line width is 50. So that would be, a typical one standard deviation is about like this. All right. Now it says find the percentile. So that means at or below, indicated in red on the dot plot. Okay, so you kind of have to look in your textbook to know which one's indicated in red. So let me flip back here. That's what happens when you make a copy of the textbook and then you don't get the color. So it says the one indicated in red, I'm just going to go ahead and erase this so it's not distracting you. The one indicated in red is the one lone dot here. Okay, so that one's indicated in red. So it says make sure that you find the percentile of that. So we're going to count them. How many are at or below him? So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So there's 27 dots at or below him. So there's 27 out of 40. So that would be his percentile. Find the percentile, so let's say right? And again, at or below means just less than or equal to, right? Now, what would be that percentile? So I'm just going to get out our calculator, right? What is the fraction? 27 out of 40. And we get 0.675. So we can say approximately the 68th percentile. And then it says, calculate and interpret the standardized score for the house indicated by the red dot, which sold for that. Okay. So we need to find the mean, right? That's 203. Again, the mean is here at 203. This is above it, so it's going to have a z-score that's positive. And we need to not only calculate it, but we also have to interpret what that means. Okay, so there's actually a lot going on in this problem. Okay. So in part B, we would say that the actual home price in this instance is this, and we'd predict it to cost the average price. all over the standard deviation. So our z-score is 0.35. And then we have to say, what does that mean? So it means, in the context of the problem, that the sale price for this home, the red one circled, is 0.35 standard deviations. So not even a full standard deviation above the mean. And what is the mean in the context of the problem? The average sale price of a home in Ames, Iowa this month. So I got in my context of my problem. All right, so that wasn't too painful. Now let's look at 2.12. It says, I'll just kind of put a box around that. That's going to be my 2.1. 2.12, the study of 2,000 able-bodied males at the University of Illinois, that's where I went to undergrad, found that their times for the mile run were approximately normal, with a mean of 7.11 and a standard deviation of 0.74. So about how many students ran the mile in less than 6 minutes. Okay, this is a lot like our review sheet, isn't it? So we want to do it by hand, right? 6 minus 7.11 over the standard deviation. That's exactly negative 1.5. So how many students would that be? Well, negative 1.5, 0, right? I don't have any decimals after that, so it's 0.668. So I look at table A and I get 0.0668. So it says about how many students. Ooh, well, it's that proportion. So that's like 6.68% of 12,000, and of means multiply. Right? So I'm going to put 0.0668 times 12,000. So that would be 8.01.6. I can't have a fraction of a man, so I'm going to say about 802 students. Now, looking at the textbook, because we have the answers, that they got exactly the same because they did it by hand. They also showed doing it using a calculator. If we were using our calculator, we'd have norm CDF, lower bound, a really low number that's already in our calculator, so we leave it in. Upper bound 6, this goes on for infinity to the left. Mean 7.11, standard deviation, that's 0.74. And it says if we use our calculator, we get, what's this say? They're saying the same number, 0.0668. So same thing, same answer. Approximately 802. Approximately how long did it take the slowest? So we got to be careful. If you're really, really slow, you're going to take more time. So 711, these are the slowest up here. So they want to know, they gave you the area under the curve. So again, in a calculator, this is going backwards. So I could do inverse norm. They gave me the area under the curve, but I have to be careful. I need the area under the curve to the left. So if that's 0.1, then this area under the curve to the left would be 0.9. The mean is still 7.11, and the standard deviation is still 0.74. And if we use our calculator, we get 8.06. So that's what this is. And we were looking for a number that was slower than 7.11. Now, how would we do this for full credit? Again, we'd have to do it by hand. So we wouldn't know this number, so we'd call it x minus 7.11 all over the standard deviation 0.74. Now we would know the z-score though, because I can look in table A and find the area of 0.90 or close to it and figure out what the z-score would be going over and up. So let's do that. Looking for the number 0.9. Oh, I think I'm going to do a little racing. I think this number is really close to 0.9. I could use either one of these. I'm going to use this one. So it looks like it's the z-score 1.28. 1.28. So if I multiply 7.4 on both sides, I get 0.74 times 1.28, and those cancel. So on this side, I'm going to add. Okay, pretty close, right guys? Pretty close, not that bad. So it took, if we round here, 8.06 for the slowest 10% to run the mile. Okay, so this was part A. This was part B. Now we get to do part C. So I'm kind of running out of room. Let's see what, maybe I can work with it here. It says, suppose that these mile run times are converted from minutes to seconds. Aha! So what do you do when you convert from minutes to seconds? If it's 7 seconds, like our mean, when we convert, 60 seconds is 1 minute, right? So I'm dividing by 60. Notice it says estimate the percent of students that ran the mile between that and that. We could do one of two things. We could just convert this back, or we convert everything in the table. So I'm just going to convert this back. So 400 seconds, right, is the same thing as 400. I have to divide by 60. So 400 divided by 60. And that's 6.67 repeat, 6.6 repeating. All right, here I'm going to do the same thing. 500 divided by 60 would give it to me in minutes. So how many minutes is that? And it's 8.3. So this is what we call a type 1C, where our mean is still 7.11. And now they want to know what's the area between 6.6 repeating and 8.3 repeating. What is the area under that curve? So to do this by hand, we've got to do 2. But in norm CDF, it goes pretty fast. So in norm CDF, we have our lower bound, our upper bound, our mean, and our standard deviation. Now, notice in the book, they converted the mean and the standard deviation. You could have also done that. You should get the same answer, okay? So the area under the curve is, all right, that, and then it just said estimate the percent. So we have to convert that to percent, 67.6%. Now, how would we do this by hand? Again, in the book, they converted the two. So again, you could have totally done that. You could have converted the mean to seconds by multiplying by 60, and then converted the standard deviation. And again, remember the mean and standard deviation change when we multiply, so multiply that by 60. And so you get 426.6 and you get 44.4. So 426.6. In the same way, you're looking for 400, the area under the curve, and 500. And again, it doesn't matter to me which way you do it. You just have to pick a way. And this area should be the same. It's still the same percentage, right? This percent under the curve, and we found it. So how would we do it by hand? So again, like the book did, you do that 400 actual minus predicted, divide by the standard deviation. Now the standard deviation is 44.4. And find our z-score. And go to table A and look for this 0.6 and go here, and we find the number 0.2743. All right, and then we do it again. 500 minus 426.6 all over 44.4, and we get the z-score of 1.65. So we go back to this table, 1.65, so 1.6 and then 5. We look down for this number, and it looks like the area to the left of 500 is a much bigger number. That's 0.9505. So we have to subtract these two numbers. So we have to do 0.9505, subtract 0.2743, and we get our answer 0.6762. So pretty much the same answer, would round to the same answer. There's our answer. Okay, for full credit, you got to do it by hand. I know it's not fun, but you get to use your notes, so you should be able to muddle through it if you want full credit. Now let's see. 2.13, a study recorded the amount of oil recovered from 64 wells. Here's some descriptive stats. Okay, so we kind of talked through a question similar to this. We notice the mean and the median are not the same. Not close. The mean is greater than the median. We also want to look at, or can look at, the standard deviation. How far is the standard deviation from the left and from the right? And is it equal on both sides of the min and the max? So even though we don't have all the data points, we actually have quite a lot to figure out if it's normal, because we can kind of figure what kind of shape it has. So the book talks about this one saying, no, it doesn't seem to be normal. We already can see why, but how would we get full credit on a question like this? The book says, and I completely agree, no, it's not approximately normal because, so first we have to say yes or no, then we have to say our statement, then we have to say why. There is a large difference between the median and the mean. And we know in normal data, the median and the mean would be the same or very similar number. They would be close, right? These are the respective values. So the other thing we notice is the distance between the minimum and the median. So we can also see if something is symmetrical. So not just the mean and the median need to be the same, but it needs to be symmetrical. Well, if something is symmetrical, the distance between the median and the max should be about the same as the distance between the minimum and the median. Those should be the same. So the distance between the median, if the min was 2 and the median was this, right? Then the distance between them would be this. And now let's compare the upper half. So if the maximum was 204.9, and again, the median is still 37.8, we get 16710. So I drew a picture, but in fact, this max is a lot further away. Right? This is 35. This is 167. If I divide those two numbers, 35, that's 5. So my picture is really off. In fact, the way these numbers are, this side is 5 times longer. So it might look something like this. If the median is 37.18 on a number line, this is a lot, 5 times longer to get up here to the max. So that would be another reason it is not symmetrical. There's a big difference between the median and the mean, and it's not symmetrical because the distance from the median to the min is lots less than the median to the max. It definitely doesn't do 3 nice flaps. Now, what else does it say? It says in a normal distribution, these should be the same. Yeah. Because the mean is larger than the median, the distance to the median and the max is larger than the distance to the minimum. So therefore, we know it's skewed right. We also noticed in our thing, one way to say it's not normal is simply to say this is not normal because it's skewed right. So declare that it is skewed is a way to support that it's not normal. Thanks for joining us, guys. Best of luck. See you.